Okay, so today I'm going to talk about automatic knowledge graph construction with LLMs for hybrid retrieval and chatbot integration. So recently, LLMs have exploded in their popularity due to their recent innovations in their capabilities. For example, here in the green panel, you can see an application also known as using LLMs for chatbots, where a human user would provide a query and then an LLM would provide an answer. But LLMs in chatbots often struggle with factual accuracy, and especially for specific or recent information, leading to what is known as hallucination, like for example in this red panel in the upper right corner there, where it might admit ignorance or just make up an answer, which is also known as hallucinations. And a recent method is known as Retrieval Augmented Generation, or RAG, aims to resolve this issue by, as you can see in the blue panel, where the user provides a query, and that query is delegated to a separate knowledge base, which then retrieves relevant context, and that context is then augmented for the language model to provide accurate answers. And the goal of this study is to reduce hallucinations and increase reliability for LLMs in such chatbot applications. And now we will discuss the limitation of RAG, where if one were to present a system like this with complex queries, for example, as you can see, there are multiple queues and also it requires grounding. What is known as naive RAG or classic RAG, where documents is chunked to these little segments of information. They might retrieve semantically similar information, but then they might be irrelevant simply because of the limitation of the embedding model and the naive RAG approach. And a common and a recent approach to resolve this issue is to use knowledge graphs for LLMs, where they delegate the explicit connection and reasoning to a knowledge graph, such as in the illustration right here, where we have head entities such as Sam Bankman-Fried, which is a human here, and then we have tail entities such as FTX customer funds, fraud, stake in Binance, and those tail entities are connected through relations like using, accused of, purchase, and related, and so on. But they're still missing context relevant and source grounding in regard to the query here. So our proposal is that we will combine them to the delegate this to a hybrid graph RAG retrieval, where we take the best of both worlds. We connect the text chunks to the knowledge graph themselves and have a hybrid of text chunks and knowledge graph. And here is the overview of the relevant knowledge base that we just discussed. For example, you can see that vector database, which is characteristics of naive RAG, might get semantically similar information but then provide irrelevant answer, failing to produce a reasonable output. And then for a knowledge graph, it does improves upon RAG, but then the best answer here is marked with a yellow star, where we use the hybrid knowledge base, connecting both the text chunks and utilizing the knowledge graph. And to verify this idea, we propose a hybrid graph RAG pipeline, where with an offline phase and an online phase. And here on the illustration you can see a demonstration of the offline phase and the online phase. And now we will go over the offline phase first, which starts with chunking and cleaning of documents. So as you can see, in the documents there are usually these paragraphs of text of information that might be malformed or have some sort of unclean text, unstructured text, and we can chunk them and clean them to produce what is known as these little segments of information, as you can see on the right side. And after we have these chunks, we then go through an LLM driven entity and relation extraction, where we prompt an LLM to produce these valid JSON schemas for later, where we construct knowledge graphs. And then we construct the knowledge graph using that hybrid structure we just mentioned, where documents is also connected to entities via a mentions relation. And finally, we integrate it with a Neo4j database, which allows for efficient and extraction of information. And next we go through the online phase, where a user would provide a query, and then the LLM will an LLM will extract entities from the queries, and these entities will then be used to retrieve relevant context from the graph structure, and at the same time similarity search is then performed to be able to retrieve the document nodes that are connected to the entity nodes, providing a much more rich context for the model to generate an answer. And as you can see, here's the demonstration of that answer produced from the given query. And to really verify this methodology, we ran an experiment on the multi-hop RAG benchmark. And the multi-hop RAG benchmark, introduced in 2023, contains about 600 English news articles with a QA dataset of around 500,000 queries. And the experimental setup, we use a single RTX 3060 with 12 GB of VRAM, and due to this limitation, we only evaluated 10% of the multi-hop RAG query. And for the graph construction model, we used Qwen 2.57b. For the answer generation model, we also tested Qwen 2.5 at various parameter counts, such as 3 billion, 7 billion, and 14 billion. All of these Qwen 2.5 models are at Q4 quantization. And for the embedding model, we use Nomic Embed Text v1.5 at Q8 quantization, and we decided to use an LLM judge to evaluate the QA performance of these Qwen models, because sometimes it provides for a more thorough and nuanced evaluation compared to just simple text matching. And it also allows for the Qwen models to be unrestricted in their answer generation to really pull out their potential. So for that LLM judge, we use Mistral 7b Instruct v0.3 due to various experimentations where we found that this model judged the best of various other models. And here's the constructed knowledge graph from the offline phase that we ran. It took about 14 hours to index all of those 600 news articles, and resulting in a Neo4j database with around 50,000 nodes and 100,000 relations, also including the mentioned relationships that connects documents to entity nodes. And here are the QA evaluation results, and we can clearly see that hybrid strategy consistently outperforms all other context strategies. And another pattern is that larger models benefits most from combining both graph and chunk-based context, and providing external context boosts accuracy of the no context baseline. And through these endeavors, we have concluded a few challenges in building autonomous knowledge graph pipelines. Is that combining knowledge graphs with RAG enhances performance is still conceptually practically difficult. LLM-based knowledge graph construction is far from solved, often relying on trial and error and manual interventions. And we also notice a pattern is that there seems to be a mismatch in utilizing LLM and knowledge graph together, as probabilistic LLMs doesn't seem like a fit for deterministic graph schemas that these kind of systems are going for, and significant time and effort are required to actually build these stable and robust scalable knowledge graph pipelines, especially when we are using smaller models where they might struggle with tasks like instruction following, long context reasoning, and function calling. And for future directions, we propose a more unified and robust encourage for a more unified and robust framework to work with LLM-centric system, as most of these frameworks, such as LangGraph, LangChain, they're still very experimental, and they doesn't seem to be unified. There are various versions of them, and they seems to be more dispersed in their versioning. So there's that. And then we also propose a better understanding of factual claims in the unstructured semantic text, potentially going for and more elegantly combining heuristic and probabilistic components in order to really harness the information in these unstructured texts, especially from classical NLP. And more importantly is that domain expertise is often required for the specific task at hand, as this system where we develop were aimed to solve a kind of more of a generalized problem, so it doesn't perform as well as it might have been if we specifically tune it for these for the multi-hop RAG benchmark. So in conclusion, hybrid RAG system does improve chatbot performance on multi-hop queries by combining knowledge graph construction with LLMs. And the hybrid approach consistently outperforms traditional RAG baseline, especially as the size of the model scales. And the challenges include manual tuning, instability, and scalability issues with autonomous knowledge graph construction, and the tension between probabilistic LLMs and deterministic knowledge graphs suggests a need for more robust, logically aligned systems. And here are our main references, and thank you for listening.